The Earth is full of giant holes and scars that can take your breath away. Some were made when huge space rocks crashed down.
Perhaps this is just nature's way of giving us the flip.
Others from fiery blasts deep underground, and some from the land suddenly caving in. These craters are so big, some can be seen from space. Each one holds a story of power, danger, and change. Get ready to explore 15 of the biggest and most amazing craters on our planet and discover the wild secrets they keep. Number 15. Sudbury Basin. The Sudbury Basin in Ontario, Canada, is one of the largest and oldest impact craters on Earth. It formed about 1,850,000,000 years ago during the Paleoproterozoic era. Back then, a huge comet or asteroid, estimated to be 6 to 9 miles wide, struck the Earth at incredible speed. The force of the impact was enormous, releasing more energy than billions of nuclear bombs. This explosion carved out a massive crater, originally about 120 to 155 miles wide and several miles deep. Over billions of years, erosion and geological forces reshaped it into the oval we see today, about 37 miles long, 19 miles wide, and up to 9 miles deep. The heat and pressure from the impact created special cracks in rocks called shatter cones, which can still be found there today. The collision also melted part of Earth's crust, forming the Sudbury Igneous Complex, a layer rich in metals. As it cooled, valuable minerals like nickel, copper, cobalt, platinum, gold, and silver settled at the bottom. This made the Sudbury area one of the richest mining regions in the world. Mining started in the late 1800s and continues today, powering industries beyond Canada. NASA even trained Apollo astronauts here to help them recognize impact rocks before their moon missions. Number 14. Popigai Crater. The Popigai Crater is a huge, nearly perfect circular impact site in northern Siberia, Russia. It measures about 62 miles across, making it one of the largest known craters on Earth. The crater formed roughly 35.7 million years ago during the late Eocene epoch. At that time, an asteroid, likely a stony meteorite called an H-chondrite, about 3 to 5 miles wide, crashed into Earth at nearly 12 miles per second. The impact released enormous energy, instantly vaporizing rock and creating intense heat and pressure. This transformed underground graphite deposits within an 8 to 9 mile radius into special polycrystalline impact diamonds. These diamonds range between 0.5 and 2 millimeters, though some can reach 10 millimeters. Stronger than normal diamonds, they are more useful for industrial tools. Scientists estimate the crater may hold trillions of carats of these diamonds, possibly 10 times the world's known reserves, enough to supply global needs for 3,000 years. Its remote location means it is rarely visited, but remains a valuable site for scientific study. Number 13. Acraman Crater. Around 590 million years ago, during the Ediacaran period, a giant asteroid slammed into what is now South Australia, creating the Acraman Crater, one of the largest known impact sites on Earth. Today, its center is marked by Lake Acraman, a seasonal salt lake about 12 miles wide. But scientists believe the original impact structure was between 53 and 58 miles across, with some estimates stretching to 93 miles when including its outer rings. The collision released an energy equal to millions of megatons of TNT, far greater than the combined power of all nuclear weapons ever made. Evidence confirming its impact origin includes shatter cones and shocked quartz found on rocky islands within the lake, features only produced by extreme pressure and heat during meteorite strikes. The event threw debris, known as ejecta, hundreds of miles away, with layers of this material found in marine sediments across South Australia, even altering microfossil communities such as acritarchs, tiny plankton, that flourished before the blast. These biological changes hint that the impact may have influenced the course of early life on Earth. Today, the crater is heavily eroded and partly buried, making it invisible from ground level. But from space, the circular outline of Lake Acraman reveals its ancient, violent past. Number 12. Morasko Craterfield. The Morasko Craterfield, also known as the Morasko Meteorite Nature Reserve, lies on the northern edge of the city of Poznan in Poland and was officially protected as a nature reserve in 1976. It features 7 meteorite craters nestled on the southern slope of Morasko Hill, which itself stands at 505 feet above sea level, formed by glacial action. The largest crater measures approximately 100 meters in diameter and about 11 meters in depth, with some sources suggesting the depth may reach up to 13 meters, even after thousands of years of erosion. Scientists estimate the impact occurred around 5,000 years ago during the Holocene epoch. Inside and around these craters, one can discover peaty lakes. 5 of the 7 craters contain water, and glimpse rare plants like the Turk's cap lily, wild ginger, and tropical hornwort, as well as birds like the European nightjar and the black woodpecker. The first meteorite fragment was found by German soldiers in 1914, weighing 1,700 pounds, and later finds include a 360-pound meteorite in 2006 and around 661 pounds in 2012. Number 11. Woodleigh Crater. Imagine a huge crater hidden deep under Western Australia called the Woodleigh Crater. It was discovered by 4 scientists from the Geological Survey of Western Australia and the Australian National University. The discovery was first reported on April 15, 2000, in the journal Earth and Planetary Science Letters. This crater is buried beneath younger rocks, so it cannot be seen on the surface. Its diameter might be between 37 and 74 miles, and some studies suggest it could be even larger, possibly more than 62 miles. In the middle of the crater is a bulge called the Central Uplift, which is about 12.5 miles wide. Scientists first drilled there in the late 1970s, but only realized it was caused by a meteor impact after gravity surveys in 1997. When they drilled again in 1999, they found melted glass, broken rocks called breccia, and shocked quartz. These minerals only form under pressures 100,000 times greater than air pressure at sea level, which is 10 to 100 times stronger than pressures caused by volcanoes or earthquakes. In 2018, scientists discovered one of Earth's rarest minerals called rhyolite, which forms from zircon under extreme pressure. This discovery supports the idea that the crater is probably larger than 62 miles, making it possibly Australia's largest known impact crater. The impact happened about 364 million years ago during the late Devonian, a time of major extinction, raising questions about its role in that event. Number 10. Boltysh Crater. The Boltysh Crater, also called the Boltysh Crater, lies buried beneath Kirovohrad Oblast in central Ukraine near the village of Boltyshka. It is located in the basin of the Tyazmin River, a tributary of the Dnieper River. The crater is about 15 miles wide and 1,640 feet deep. Around it is a layer of broken rocks called breccia, covering over 2,510 square miles. After the impact, ejecta, material thrown out, spread across about 9,650 square miles, at least 3 feet thick, and up to 2,000 feet near the rim. Inside, a central uplift about 4 miles wide rises 1,800 feet above the crater floor, but is now buried under 1,600 feet of sediment. Discovered during oil shale exploration in the 1960s, the crater is dated to about 65.39 million years ago. This is 650,000 years younger, so it is not directly linked to dinosaur extinction. Recent studies link it to early Daunian warming, helping study Earth's recovery. Number 9. Serra da Cangalha Crater. Serra da Cangalha Crater is a confirmed impact crater in Tocantins State, Brazil, near the Maranhão border. It lies within the Parnaíba Sedimentary Basin and spans about 7 to 8 miles, making it Brazil's second-largest known crater. Its age is estimated at around 220 million years, dating back to the Triassic period. The crater's shape features a circular inner escarpment about 7 miles wide, with several rings. A faint 6.8-mile ring, rolling hills 3 to 5 miles wide, and a steeper inner ring about 2 miles across that rises up to 1,400 feet above the land. This ring surrounds a central depression roughly 1.3 miles wide. Scientists confirmed its impact origin through features like impact breccias, shatter cones, and shocked quartz. Satellite data and magnetic surveys have mapped the crater's structure and deformation to depths of about 1.2 miles. The meteorite that formed it was estimated to be about 4,500 feet wide. The crater was first identified as an impact site in 1973 and has been studied extensively since. Number 8. Lake Lappajärvi. Lake Lappajärvi is a meteorite-formed lake in South Ostrobothnia, Finland. It was created about 78 million years ago during the late Cretaceous, when a meteorite roughly 3,300 feet wide crashed into the area at cosmic speeds. The impact destroyed life for hundreds of miles and formed a crater about 14 miles wide, with rim walls around 2,460 feet high. Over millions of years, tectonic movements and glaciers eroded the crater, but the elevated rim is still visible from places like Lappajärvi in Vimpeli and Pihavori in Lappajärvi. The crater's central uplift is now Kärna Island, made of a rare hard rock called kärnite that helped preserve the structure. Nearby, scientists found suevite, a fragile rock mix that contains rare impact diamonds found in only 3 craters worldwide. Lake Lappajärvi covers about 57 square miles, with a maximum depth of 118 feet and an average depth of 24 feet. In 2024, it was officially named a UNESCO Global Geopark. Number 7. Lonar Crater. Lonar Crater is a unique natural wonder in Maharashtra, India. It is a nearly perfect circular crater, about 6,000 feet wide and 165 feet deep, formed around 50,000 years ago when a meteorite struck the Earth at high speed. Unlike most craters found in sedimentary rock, Lonar Crater formed in basalt, making it one of only 4 known basalt craters on Earth and the only one in India. Inside the crater is Lonar Lake, a salty and alkaline lake that supports special bacteria and microorganisms able to live in harsh conditions. Scientists study this lake to learn about these extremophiles. The crater area is protected as a National Geological Monument and attracts many tourists and researchers. British geologist D.B. Carr officially discovered it in 1990, though locals knew of it much earlier. In 2017, the Indian government declared Lonar Crater a National Geo-Heritage Monument to protect its scientific and natural importance. Number 6. The Vredefort Crater. The Vredefort Crater is the largest confirmed impact crater on Earth. It is located in South Africa and measures about 186 miles in diameter, which is nearly 186 miles across. This huge crater was formed around 2 billion years ago when a massive asteroid or meteorite crashed into the Earth. The impact was so powerful that it created a dome-like structure in the middle called the Vredefort Dome. Scientists believe the original crater was even bigger, but weather and erosion have worn it down over time. The Vredefort Crater is part of a World Heritage Site because it helps researchers understand how large space rocks affect our planet. The impact released energy more than 10 million times that of the atomic bomb dropped on Hiroshima. The rocks show signs of extreme heat and pressure, proving the force of the collision. People visit to learn about its history and see its unique landforms. Number 5. The Zhamanshin Crater. The Zhamanshin Crater is a large impact crater located in Kazakhstan, in Central Asia. It measures about 8.7 miles in diameter, making it one of the bigger craters on Earth. Scientists estimate that it was formed approximately 700,000 years ago during the Middle Pleistocene epoch, a period when early humans were starting to appear. The crater was created by a meteorite, a space rock that crashed into the Earth with tremendous force. This impact caused a huge explosion, throwing rocks and dust high into the air and forming the round depression we see today. One interesting fact about the Zhamanshin Crater is that it may be the source of special natural glass called tektites. These tektites are formed when the meteorite impact melts the Earth's surface, and the molten material cools quickly into glassy fragments that can be found far from the crater. Scientists study these tektites to learn more about the impact event and the meteorite itself. The Zhamanshin Crater is not very deep because over many thousands of years, wind and rain have worn it down and filled it with sediments. It is located in a remote area covered mostly by steppe, which is a grassy plain. This crater is less famous than some others, like the Chicxulub crater in Mexico, but it remains important for research on meteorite impacts and their effects on the Earth. Number 4. Mistastin Crater. Mistastin Crater is a large round impact crater located in the province of Newfoundland and Labrador, Canada. It is about 17 miles wide, making it one of the bigger craters on Earth. This crater was formed around 38 million years ago when a huge meteorite hit the area with a lot of force. The impact was so strong that it created a big hole, which was later filled with water, forming Mistastin Lake that perfectly fits the shape of the crater. The crater is part of a larger volcanic and geological area and is very interesting to scientists because it helps them learn about how big space rocks hit Earth in the past. Mistastin Crater is also famous for having special types of rocks called impact melt rocks. These rocks were melted and changed because of the heat and pressure from the meteorite strike. Scientists study these rocks to understand more about the impact process. The crater lies in a remote area, surrounded by forest and wilderness, so it is not easy to visit, but it is a great place for researchers who want to explore Earth's history. Mistastin Crater is also part of Canada's natural heritage and shows how powerful natural forces can shape the Earth's surface. The meteorite that created the crater was estimated to be about 3,300 feet wide before it hit the Earth. The shape and size of Mistastin Crater help scientists compare it to craters on the Moon and Mars, which gives clues about the history of our solar system. Number 3. Shoemaker Crater. Shoemaker Crater is a large impact crater located in Western Australia. It is named after Eugene Shoemaker, a famous planetary geologist who studied craters on Earth and other planets. The crater is about 18.7 miles wide and was formed a very long time ago, around 350 million years ago, during the late Devonian period. This means it is older than the dinosaurs. Shoemaker Crater was created when a huge meteorite, a space rock from outer space, hit the Earth at a very high speed. The impact made a big hole in the ground and caused a lot of damage to the surrounding area. The crater is mostly buried under sand and rocks, so it is not easy to see from the surface. Scientists have studied Shoemaker Crater by using special tools like satellites and drilling into the ground to learn more about it. The crater has a central uplift, which is a raised area in the middle formed by the force of the impact pushing rocks upward. Around the crater, there are shattered and melted rocks that show the power of the impact. Shoemaker Crater is important for scientists because it helps them understand how meteorite impacts change the Earth's surface and how similar craters may look on other planets like Mars. The crater is also part of a region with other ancient craters, which shows that this area was hit by many meteorites long ago. Number 2. Beaverhead Crater. The Beaverhead Crater is a huge impact crater located under parts of the states of Idaho and Montana in the United States of America. It is estimated to be about 37 miles wide, making it one of the largest impact craters on Earth. Scientists believe this crater was formed about 690 million years ago during the late Precambrian time. The crater was created when a very large asteroid or meteorite hit the Earth with great force, making a deep, round hole in the surface. Because of the long time that has passed since the impact, the Beaverhead Crater is not visible from the ground today. It is mostly buried under layers of rock and earth. Researchers found evidence of the crater by studying the rock layers, using methods like magnetic surveys, seismic studies, and drilling deep into the ground to collect samples. The discovery of shocked quartz and other minerals helped prove that this was caused by an impact from space. The Beaverhead Crater is important for scientists because it helps them understand how big space impacts change the Earth's surface and its history. Studying this crater also gives clues about the Earth's geological events during the Precambrian time, which was before complex life forms appeared. The Beaverhead Crater is one of several large craters found in North America that help tell the story of Earth's early years. Because it is buried and very old, scientists are still learning new things about it. Number 1. The Kamensk Crater. The Kamensk Crater is a large impact crater found in Russia. It is about 15.5 miles wide, making it one of the bigger craters on Earth. Scientists estimate that this crater was formed a very long time ago during the late Devonian period, which is about 370 million years ago. The crater was created when a meteorite or asteroid hit the Earth at a very high speed. This collision caused a huge explosion that made a big hole in the ground, which is the crater we see today. Over millions of years, the crater has been worn down by weather and other natural processes, so it is not very clear or perfectly round anymore. Despite this, scientists study the Kamensk Crater to learn about the history of asteroid impacts and how they affected Earth's environment and life. The rocks around the crater show signs of intense heat and pressure, proving that a powerful impact happened there. The crater also gives important information about the geology of the area and how the Earth changed after the collision. Because the crater is hard to see and visit, it is not very famous outside of science, but it is very valuable for researchers who study Earth's past. The age and size of Kamensk help scientists compare it with other craters and understand how asteroid impacts might have influenced climate and life millions of years ago.